Welcome to the Joanne Avison podcast. Recently, I posted a podcast about us being sacred geometry, and it was all about tensegrity. And I wanted to share with you something that's happened. It was actually a while ago, but it's very relevant to the conversation since there was so much feedback from it, and so many people have written to me and contacted me about it. This came from a student who studied one of my online courses. And in this course, it's a comprehensive course for yoga teachers specifically, learning about fascia and how to integrate fascia and the principles of tensegrity into yoga practice. So it's part of the Arhanta Academy, the online school. And the whole course is very specific. And studying that course was somebody who wrote to me about tensegrity. And she had gone to ChatGPT to ask for assistance in understanding a particular point that I made. She had a response from ChatGPT that troubled her because it didn't make sense of what I'd said. And out of fascination, I asked one of my dear friends and colleagues, John Sharkey, what do you think? And he came back with the most brilliant response. But it depended on the question. So I really invite you to consider these two pieces of information. I'm going to read them. So you'll see me reading because I want to honour both people involved in this conversation and make sure that I get their wording right and get ChatGPT's two entirely different responses on the same day right as well in my reporting. Please listen through, because what it tells us is not so much about the knowledge we have, but about the questions we ask in order to establish, grow, transcend, and evolve that knowledge into wisdom that we can all use. So here is, first of all, the lovely email that I got with the gentle question that this particular participant in the course had written. Hi, Joanne. I am currently taking your course on fascia for yoga teachers. Thank you so much for all your work and what you share. I'm about a third of the way through and I'm loving this so much. I have a definite metaphysical bent in my learning interests, and I frequently like to consider things beyond the scope of where it feels like conventional science often resides. With that said, I'm trying to better understand how we are high-frequency icosahedrons. Side note from me that that's the explanation of the sacred geometry by which every cell in our body abides, the geometry of the icosahedron. Back to the person's email. When I use Ask AI, which I know has its limits, it says the following, and ChatGPT says something similar too. And this person very kindly summarized ChatGPT's response and the AI response. Her question was, are we made up of high-frequency icosahedrons? This is the response. To address the question of whether humans are made up of high-frequency icosahedrons, we must first clarify what is meant by high-frequency icosahedrons and how this concept relates to human biology. Understanding icosahedrons and frequency. An icosahedron is a geometric shape that consists of 20 equilateral triangle faces. In the context of geodesic domes, frequency refers to how many times each triangular face is subdivided into smaller triangles, which increases the structural integrity and spherical appearance of the dome. A higher frequency means more subdivisions and thus a more complex structure. In biological terms, while the concept of an icosahedron can be metaphorically applied to certain structures in nature, such as viruses, it does not directly translate to human anatomy or cellular structure. Humans are composed primarily of cells which are made up of various molecules, including proteins, lipids, carbohydrates, and nucleic acids. These molecules themselves can have complex shapes, but do not inherently take on the form of high-frequency icosahedrons. Note from me, that's just wrong. However, we continue. New heading, biological structures and geometry. In biology, certain viruses exhibit an icosahedral symmetry. For example, many viral capsids, the protein shell enclosing the viral genome, adopt an icosahedral shape because this configuration allows for a stable structure with minimal energy. However, this is specific to certain viruses and does not imply that human beings or their cellular structures are composed of such geometries. Side piece, where did you get that shit? Carry on. Human cells do exhibit complex geometrical arrangements at various scales. Oh, so they do actually represent round things, which are icosahedral, but we won't go there. That's me being sarcastic. At various scales, such as tissues organized in specific patterns, but these arrangements do not conform to the mathematical definition of high-frequency icosahedrons. Really? Who's doing the math? Sorry, back to what it says. Instead, they reflect a variety of biological processes influenced by genetic programming and environmental factors. In summary, while there are geometric principles in nature that can be observed in various biological forms, including some that may resemble or utilize aspects of icosahedral geometry, humans are not made up of high-frequency icosahedrons, i.e., just for everybody out there, round things. Okay. Our bodies consist primarily of cells, they're not round things, organized into tissues and organs that follow biological rather than purely geometric rules. Somebody needs to tell ChatGPT that biology follows geometry if you're talking real living things. But I digress again. Final answer from ChatGPT and AI. No, we are not made up of high-frequency icosahedrons. So this lovely, lovely person said, how do you bridge this in sharing about our geometry or shapes biologically about being high-frequency icosahedrons? I'd like to make sure I'm understanding this right, as it's so cool and fascinating. Thank you. God bless you. You know who you are. I'm not going to name you. Thank you for that fabulous email, and I was really moved to receive it. And I so appreciate the integrity from which your question comes. I wrote to my very dear friend, John Sharkey, as I told you, and his response was something about how much we should trust AI or ChatGPT. Firstly, you have to ask the question correctly. Otherwise, ChatGPT will not grasp the nuance of what it is you're inquiring about. Let me give you a very clear and concise example. Writing the question to ChatGPT in a very specific way to explain the research of Donald Ingber showing that living cells are constructed upon high-frequency icosahedrons. And here's the response from ChatGPT. Are you ready, guys? Fasten your seatbelts, because this is so much fun. Dr. Donald Ingber's research provides a compelling framework for understanding living cells as high-frequency icosahedrons. The icosahedron, with its 20 triangular faces, is one of nature's most efficient geometric shapes for distributing mechanical stress. This efficiency makes it a recurring motif in both natural and human-made systems, from viral capsids to geodesic domes, and now in cellular structures as conceptualized by Ingber. Side piece from me, please note, Ingber wasn't attempting to conceptualize the human cell. He was investigating it and bringing his questions to it to find out what it revealed to him. Let's be clear. Back to John's response, or ChatGPT's. To grasp why cells are described as high-frequency icosahedrons, it's important to explore the dual meanings of frequency. Geometrically, frequency refers to the level of subdivision in an icosahedron's triangular faces. A high-frequency icosahedron has each face subdivided into many smaller triangles, creating a smoother, almost spherical form. This geometric refinement mirrors the intricate organization within living cells, where countless components work together to create a coherent and adaptable structure. However, frequency in this context also refers to something deeper: vibration. All matter, whether animate or inanimate, vibrates at characteristic frequencies. living cells are no exception. The molecular components of cells, such as cytoskeletal filaments, resonate and vibrate, influencing their interactions and responses to the environment. These vibrations aren't merely passive. They play a vital role in processes like communication within the cell, mechanical signaling, and even how genes are expressed. Side piece, me dipping in. Please note that vibration is the fact that we're living. That's what denotes that we're alive. It was what distinguishes us from one that doesn't vibrate and change, i.e. dead structure. Just saying. I continue with the quote. Ingber's Tensegrity model of cellular mechanics ties these ideas together beautifully. Tensegrity structures like those observed in cells balance tensile forces in structures like actin filaments, it's just an example, with compressive forces in elements like microtubules. This dynamic balance enables cells to efficiently adapt to mechanical stresses, maintain their shape, and coordinate activities. The icosahedral geometry of this model enhances its efficiency, distributing forces evenly and reducing the energy required for structural stability. I'll unpack this in another episode, just making the point here that ChatGPT, when given the right question, answers the opposite. We continue. Beyond mechanics, the vibratory aspect of living cells reflects universal principles. Quantum physics teaches us that everything vibrates, from subatomic particles to galaxies. Cells, as living systems, vibrate within specific electromagnetic and mechanical frequency domains. This resonance is not just theoretical, it's measurable in phenomena like membrane potentials and ion channel activities. The concept of the high-frequency icosahedron elegantly integrates these vibrational properties, suggesting that cells operate as both geometric and energetic entities. Did you hear that, guys? I will unpack all of this more later, but it's beautiful, it's brilliant. And in my last podcast about sacred geometry, I referred to this, so I'm going to go deeper on it. We can't afford not to know this. It confirms the sacred nature of our architecture, as well as our beingness. Just to finish up, the beauty of this idea is its universality. Hello, all is one. The icosahedron's geometric stability and efficiency are echoed in the natural world at every scale, from the molecular to the cellular and beyond. Don't you love it when ChatGPT gets poetic? It allows us to see the living cell not only as a physical structure, but also as a dynamic vibrating system that reflects the underlying patterns of the universe. Hello, inner cosmos. In this way, Ingber's work invites us to think of cells as both marvels of engineering, you're the engineer in this case, and participants in a greater cosmic dance where form and frequency, geometry and vibration come together to define life. Thank you, John, for being the mature, knowledgeable expert that shone light on reality by asking the right question. Why am I recording this with such passion? Because it matters. It matters to me that we understand how the fascial matrix, we could maybe find a better word for it. But to those of you saying there's no such thing as fascia, wake up and smell the frickin' coffee. We are a matrix. We are an organizing form that incorporates corpus body in living form, the dynamics of the universe in which we reside, the cosmos. My hero, Leonardo da Vinci, understood that, incorporated in his drawings, not just Vitruvian Man, but so many others, is that geometry. It's so complex. That image is so complex, I can't even tell you. And I believe the Tensegrity icosahedron exists within it, but that's something, in fact, I know it does, but it's an extrapolation and something I've got to do in animated form when I do. But here's my point. Depending on how you ask and depending on how much reverence you give ChatGPT, or AI, you also need to know that the nature of the question defines the nature of the answer. And what we think we know might not be true. Keep asking questions, keep wondering. And please, 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 two things. Understand, your cells in and of themselves animate the sacred geometric form of the Tensegrity icosahedron, because Kenneth Snelson had the genius ability to demonstrate that form and make a sculpture out of its principles. Genius. Buckminster Fuller extrapolated from that and called it Tensegrity. Donald Ingber took it into cellular biology. Why would nature not keep the most efficient, exquisite force transmission architecture vis-a-vis the first answer we heard, just for viruses, and not grant it to the top of the food chain? Really? Doesn't work like that. We incorporate genius in here. It's exquisite. And that vibration, that frequency, that understanding of the different frequencies of the different shapes of us, the forms of us, and how we transmit through those forms is so subtle. May Wan Ho considers it, or reminds us to consider it, like an orchestra of multiple octaves. I think she says a range of 80 octaves. We can't even imagine what's going on in here. And the way light and sound are transmitted through us. It's beyond belief. We have to open ourselves from the idea of reasoned argument and 400 years of history into the possibility of wonder and awe of nature herself, with grace and with a willingness to understand that we are part of that nature, we are an expression of that nature, and there's more to it than we think. All my love. God bless.